Hey everybody, this is the second logarithm review video for the summer work packet. This one goes with page 5, where it has 6 problems asking you to solve exponential and logarithmic equations. I'm going to show you one example of each. So first I will do an exponential equation, and on the next page I will do a logarithmic equation. These are similar to the ones on your packet. What you need to remember is that in order to solve these, we have to use the inverse properties of exponentials and logarithms. So in this exponential equation, I have an exponential term here. 5 is my base, and x plus 4 obviously is the exponent. What we need to do first is you're always going to need to isolate the exponential term. So that means I need to isolate 5 raised to the x plus 4. So let me do that first. That's just some basic algebra here. So I have 2 times 5 to the x plus 4 equals 3. What you need to keep in mind is that the base of the exponent is 5. Not 2, not 2 times 5, not 10, it's just 5. So you need to get rid of this 2 as well. So I have 5 raised to the x plus 4 equals 3 halves, or 1.5, whichever you prefer. This is where we need to use inverses. The only way to get this exponent by itself is to get rid of 5. Now, the only way to get rid of the 5, you can't just divide each side by 5. That won't help. You can't do the 5th root either. Some people try to do the 5th root. That's not really going to do anything either. What we need to do is logarithm. So the most common way, the way that I'll be doing it mostly next year, is to do the logarithm of each side. Let me move this over a little bit here so I can actually fit what I'm trying to do. So I had 5 to the x plus 4 equals 3 halves. And what I'm going to do is take the logarithm of each side. The best way to do it is to strategically do this so that you give the logarithm the correct base, so that this 5 that you were trying to get rid of cancels. So if I give this logarithm base 5, well, log base 5 of 5 cancels, and then x plus 4 is alone. And look, now x is not an exponent anymore, it's on the main level, and it's going to be very easy to get alone. Now I have this log base 5 of 3 halves, or log base 5 of 1.5. So what you need to do is go on your calculator and evaluate this. So you need to use change of base. You can do log divided by log, or you can do natural log over natural log. What you need to remember is that the base goes on the bottom, or you can drop the base, and 3 halves this number will always go on top. So I have log of this number divided by log of this number. If you do that on the calculator, you will get the same thing. It ends up being 0.252 rounded. The only thing you need to do now is subtract 4 from each side to get x alone, and you get negative 3.748. Next problem, let's do a logarithmic equation. So again, to undo it, we're going to use its inverse, which will be the exponential. Now, notice right here I said we still have to isolate the logarithmic term before doing anything else. In this problem, the logarithmic term is natural log of 2x minus 1. So this has to be completely by itself on one side of the equation before we can even think of using exponents. So I'm going to do the basic algebra quick to get it alone. 2x minus 1 equals 2. I have to get rid of the 7 halves. You could divide by 7 halves or multiply by its reciprocal 2 sevenths. Either one is fine. So natural log of 2x minus 1 equals 4 sevenths. Alright, now the logarithm is by itself. This has a base of e. You don't need to write the e there, but just keep in mind it is an e. So what I'm going to do is use exponents. And what I'm going to do is one way of saying it, a couple math books call it this, not every book, but some refer to it as exponentiating. You need to make each side an exponent and give it a base. So, I'm going to make natural log of 2x minus 1 an exponent. I'm going to make 4/7 an exponent. I need to give each exponent a base. So we want this to cancel, remember. We want 2x minus 1 to be completely on its own. That means natural log needs to leave and cancel out. The only way to do that is to give it a base of e. Where are you working? There we go. And what you do to one side, you need to do to the other. Oh my god. There we go. So e raised to the natural log of power, they always cancel. So I have 2x minus 1 equals e raised to the 4/7. And this, you're just going to do on your calculator and evaluate it. E raised to the 4/7 power. Did I do that out? Yes, I did. So let's move over here. I have 2x minus 1. E raised to the, sorry, my pen is freaking out right now. Hold on. Okay, continuing where I left off right here. I had 2x minus 1 equals e raised to the 4/7. What I did on my calculator is I just typed in e raised to the 4/7 power, and I got about 1.771 rounded. What I did next is I just wanted to isolate x. So I added 1 to each side. I got 2.771. I divided by 2, and I got 1.35. Real quick, another thing that you'll see is something similar to this. Let's say I have 36 raised to the x plus 1 equals 6 to the 7x minus 4. The way you want to start this off is not by just taking the log of each side. Even if you try to do log base 6 of each side, that's all good on the right side. It's going to cancel, and you'll have 7x minus 4 here. It's not going to help you out here, though. The logarithm won't cancel at all. So what you need to do is, let me get rid of all this here. You need to rewrite 36 with a base of 6. And one possible way of doing that is rewriting it as 6 squared. The right-hand side is not changed. So now I have 6 squared to the 2x plus 1 equals 6 to the 7x minus 4. One thing, a very, very common mistake, is people don't distribute this 2. You're going to need to distribute the 2 to the x and to the 1. So that means I have 6 to the 2x plus 2 equals 6 to the 7x minus 4. Now you can use the properties of exponents that say if you have the same base on each side and they're each raised to a power, they cancel, leaving you with just the powers. So then I have 2x plus 2 equals 7x minus 4, and then you can just continue solving that basic equation. And one last thing here, if you're looking at problem F and you're not really sure what to do first, part F says log base 6 of x plus 3 plus log base 6 of x plus 4 equals 1. Before you do anything, if there is more than one logarithmic term and they have the same base, what you need to use is properties of logarithms to condense. Well, I have two expressions, x plus 3, x plus 4. The logarithms are added. So that means you're going to multiply these two things. Now you have a logarithm of one expression, and then you can exponentiate. So 6 raised to the log base 6 of this equals 6 raised to the first power. So I have x plus 3 times x plus 4. 6 to the first power is 6. Then what you want to do is FOIL, get everything on one side, so equals 0, and continue solving.